Characterization of chemical and bacterial compositions of dairy wastewaters. In this presentation, our goal is to offer you a quick summary of the research and conclusions. Please follow the links to review the research in further details. Thanks to all the authors and publishers for making this research public, thereby advancing science and innovation. High milk production has resulted in a significant increase of water consumption in dairy plants and subsequent wastewater release. Between 0.2 and 10 liters of effluents or dairy wastewaters are generated per liter of milk processed. In milk processing plants, wastewater can be classified into white wastewater or WW and cleaning wastewater CW. White wastewater is generated by the first rinsing step and has a composition similar to that of diluted milk. Cleaning wastewaters are generated at the rinsing step of each cleaning solution and contain residues of caustic and acidic cleaning solutions. To improve the sustainability of dairy plants, there is an opportunity to recover rather than discard the dairy constitutes found in effluents. The aim of this study was to characterize the chemical compositions and complex bacterial ecosystems of WW and CW from two different Canadian dairy plants. Two batches of dairy WW, single-use alkaline and acidic CW, tap water, pasteurized skim milk, and unused acidic and alkaline solutions were collected from two industrial Canadian dairy processing plants to conduct chemical analysis. The results demonstrate that the chemical characteristics of WW and CW were drastically different between the dairy plants. The variations in the content of milk solids can be explained by the duration of the rinsing step before recovery of WW samples. Very low BOD5 value was measured from WW plant A, whereas this parameter was not detected for WW from plant B as well as acid and alkaline CW. BOD5 is defined as the biochemical oxygen demand of wastewater measured in both dairy plants over 5 days under specific standard conditions. The differences in chemical characteristics and composition observed between acid and alkaline CW could be related to different CIP and sampling procedures between the two dairy plants. A total of 31 bacterial genera were identified in dairy fluids. The research demonstrates that the chemical and bacterial composition of wastewaters depends on multiple environmental factors specific to each dairy plant. Key challenges to water reclamation in dairy industries could be identified. The first is the presence of thermophilic spore-forming bacteria in WW, which could represent a challenge for their reuse due to their negative impact on the product byproduct quality. The quality of tap water used in dairy plants is a major factor since it can indirectly affect the quality of the dairy products. To expand the possibilities for using and valorizing WW, work is currently underway to evaluate the evolution of bacterial communities during concentration of WW by reverse osmosis. The final objective is to generate processed water and milk solids and to ensure optimal quality for their recovery into dairy products.